So we're talking about calculating probabilities of dependent and independent events. Once we've got that written all down, flip on over to page 41. And at the top, independent and dependent events. Skylar, Isabella, Sierra. Face forward, we're talking. Independent and dependent events. So let's think about what an independent event is. We're talking about probability, and we're talking about independent events. So what do we think an independent event might be? We have two events. They're independent. Jordan. They're by themselves. So the probabilities, what do you think about their probabilities will be affected or not affected? They're not affected by each other. So an independent event, we're going to go ahead and write down a definition. Independent events. And these are events where one event does not affect the probability of the other. And the notation for this is going to be written as P, or probability of A, then B. So probability of A, and then the probability of B. And the answer to that will be the probability of A, so P of A multiplied by the probability of B, or P of B. So let's take a look at an example using deck of cards. You have a deck of cards. With no jokers. So how many cards is that? 52. There are 52 cards, so you have a deck of cards. What is the probability when you draw two cards the first card is a 4, and the second card is a diamond? They're independent, right? Has numbers and suits, right? So how many 4s are in a deck of cards? 4. So the probability of A, or the probability of 4 in this case, is 4. And how many cards did we say there were? So we have 4 favorable, 52 total. 4 favorable options, 52 total. So what's the probability of diamonds? So in a deck of cards, you have 1 through 10. And then you have your face cards. You have your jack, your queen, and your king. So there's 13 cards to each suit. A suit of cards are your hearts, spades, jacks, or
Hearts, spades, diamonds,
and clubs. So you have 4 suits. So your diamonds, you have 13 options. And you still have 52 cards. So we're looking for the probability of A, 4, then the probability of B, diamond. And we solve this by doing what? Multiplying our 2 probabilities. So the probability of A, or the probability of 4, was 4 over 52. Can you simplify 4 over 52? You can simplify to 1/13. Can you simplify 13 52nds? 1/4. So you take the probability of 4, which is 1/13, and we multiply that by the probability of diamonds, which is 1/4. So 1 times 1, and as Cameron is saying, 13 times 4 is... So there's a 1 in a 52nd chance that the first card you draw is a 4 and the second card you draw is a diamond. So this is our probability of 4, then diamond. So that's what independent probability looks like. You have 1 event and 2 events, and they're not affected by each other. So what do you think a dependent event would be? They are affected. So let's write a definition of dependent variable, or a dependent event, and then we'll look at an example. So a dependent event is an event where the first event does affect the probability of the other. So writing out what that would look like on your homework, you have P, or probability of A, comma, then B, because it's 2 separate events. So the probability of A happening and then B happening. this will be equal to the probability of A happening multiplied by probability of B after A happened. So we have the probability of A multiplied by the probability of B after A happened. So let's take a look at what an example of this might look like with some M&Ms. We're not going to eat them. We don't have any. Sorry to get your hopes up. Lunch is in like an hour. Okay, so you have a bag of M&Ms. So a bag, it'll come. There he goes. So a bag of M&Ms has 6 candies left. There are 4 red and 2 blues left. You pull out one and then another. What is the probability that both are blue? So the first thing we want to look at, once we get that written down, is what the probability of the first one being blue is. I've heard 1/6 and 2/6. What are we thinking? It's 2/6 because we have 2 blues. So the probability of the first one being blue is equal to 2/6. And we can simplify that to 1/3. Bless you. So now we need to look at the probability of blue after this blue has already been pulled out. So we have 6 candies, 2 of them are blue. We reach into our bag, we pull out 1 blue. How many candies are left? 5. And how many blues are left? 1. So that's our probability that we have our blue in there still. So we have 1/5 probability of blue after blue. So dependent events, you cannot put the first event back into the pile. So originally we had 6 events possible. Now we have 5 because we can't put that candy back in. We ate it. It's gone. And then we had 2 blues. We pulled a blue out, so there's only 1 left. So now we only have 1. So now what do we need to do? Multiply it together. We have 1/3 times 1/5. So the probability of blue, probability of blue after blue. So 1 times 1 is 1. 3 times 5 is 15. So there is independent and dependent probability. Independent probability, the first event stays and you can put it back in. Dependent, the first event happens and you have to take it out. It is no longer in the data set. So there's independent and dependent probability.